just like we estimated population proportion, we can find an estimate for the population mean, which we usually denote by mu, and find an interval using the point estimate. So point estimate of the population mean is the sample mean which we denote by x bar or mu hat, and the population mean is denoted by mu. So the process to find the confidence interval when we estimate an interval for population mean is very similar to population proportion. The only key difference is we make use of a student t-distribution instead of a normal distribution. So and similarly, instead of finding z sub alpha over 2, we are going to find a t-value, a t-critical value, which we denote by t sub alpha over 2, comma df. And I'll explain what df better as we go forward. We're not going to talk about the properties of the t-distribution. It's not necessary. I'll just show you how to find the confidence interval using the sample. So, as I mentioned, once we have a population, we can get a sample. Let's say of size n. In other words, we have n observations, and if the population mean is mu, the sample mean that we obtain using the sample is x bar. And x bar is what we call the point estimate of the population mean. So how do we find the point estimate? So here is an example about pennies minted after 1982, and the composition is 97.5% zinc and 2.5% copper. And the weights are shown here. We have 17 observations, and it is a random sample, and we'd like to find a point estimate for this particular sample. So let's go and enter the data. I have entered the sample, and now we have to find the sample mean. So we go over to one variable statistics, and we select list 1 where we have our data. So we find the mean x bar to be 2.464, and that is the point estimate for mean mu. Mu is the population mean, and it is simply the average weight Another important statistic that we need to have when we're trying to estimate the population mean is the standard deviation, specifically speaking, the sample standard deviation, which in the calculator is given by Sx. So we will just write that over here as S. We don't use it at this moment in this particular example because all we wanted to show in this example is how to compute a point estimate for the mean. But we need to have the standard deviation in order to find the confidence interval later in the example. So, just like we found a critical value with proportions using the standard normal distribution, the critical value in finding confidence intervals for mean mu is obtained using t distribution. And I'll put a note here. In contrast, we use a standard normal distribution when finding confidence intervals for population proportion P. So, of course, we need to know the area or alpha, which is the level of the So, for a given area, which is alpha in this case, physical value is 3 sub. More precisely, this is denoted by 3 sub alpha comma df, where df stands for degrees of freedom, and that only applies to a t-distribution. The degrees of freedom in our case is n minus 1, which is the sample size, minus 1. So, over here, the calculated function is inverse t. Previously, with proportion, the calculated function was inverse norm. There are some key differences that we will find today. So let us see how we can find t-values using the t-distribution. So the degrees of freedom has to be given in the problem, or the sample size has to be given in the problem, and if we have those, then we can find the critical values using the t-distribution. So we want to find the t-value under a t-distribution, so that the area to the right of the t-value is 0.2, calculator, we are going to plug in the area below or to the left of the t-value, not the area above. So that's just how the calculator is designed. So the area below here, under the curve, would be .8. So area below t-value So let us press second vars, and option number 4 is inverse t. First we enter the area below, which is 0.8, then we enter the degrees of freedom, which is 10. So that gives us an answer of 0.8791 approximately. So how did we get that? We simply did inverse t, 0.8, 10. 0.8 is the area below or to the left of t-value, and 10 is the degrees of freedom, df. So in our example, we have to construct a confidence interval for the population mean, which is the average weight of pennies minted after 1982. We found the point estimate earlier today, just right here, 2.464. The value of n is 17, and the standard deviation was 0.0176, which is why I wrote it over here 0.0177 after rounding. So since the sample size is 17, the degrees of freedom is n minus 1, which would be 17 minus 1. We end up getting 16. So what is the process? The process is to find the point estimate, which we have. The second step is to find the standard error, which is SE. The standard error in this case is the standard deviation divided by the square root of n. We know the standard deviation is 0.0177 divided by the square root of 17. We end up getting 0.004. We have the standard error now. The next step is to find the critical value, which is t sub alpha over 2, comma dx. So that is the curve we have. The area above the t-value here is alpha over 2. In a similar manner, since 0 is in the middle, the other t-value here would be negative 2 alpha over 2 df. So in the problem, we have to find a 95% confidence interval. And we know that, 99% confidence interval. We know that 99% confidence implies an alpha value of 0.01. So here the area would be 0.01 divided by 2. We end up getting 0.005. It would be the same over there. Also, that shaded area is 0.005. So second bars, option number 4, we have to enter the area below the t-value. So you can pick one of the two sides, either the positive side or the negative side. I am going to pick the negative side because I know the area below the negative critical value right here, and that is 0.005. So 0.005, comma, the degrees of freedom, which is n-1. It is not the sample size, rather it is the sample size minus 1. So we have 16. Enter. We end up getting negative 2.921. If that value on the left-hand side is negative 2.921, on the right-hand side it would be positive 2.921. The next step is to find the margin of error. The margin of error E is product of the critical value and the standard error, which in this case would be the critical value of 2.921 times the standard error. We end up getting 0.012. Once we find the standard error, the last step is to find the 99% confidence interval. Which is mu would lie between x bar minus e and x bar plus e. X bar is 2.464 minus 0.0126 and 2.464 plus 0.0126. So we end up getting the interval as 2.4514 less than mu and less than 2.477. And that is the 99% confidence interval for the population mean, which is the average weight of pennies minted after 1982. So at times, prior to starting a new study, we want to use information from the previous study to estimate a sample size so that the new study can have a reasonable sample size. In order to do that, we want to know the margin of error that we desire in finding the interval in our new study, and we have to know the standard deviation from the previous study. So that standard deviation is a known value. The E right here is the desired margin of error. So if we have a desired margin of error, and if we know the standard deviation from a previous study, then we could use this formula to estimate the sample size for the new study. So back to the pennies example, how large a sample would be required to estimate the mean of a penny manufactured after 1982 within 0.005 grams with 99% confidence, and we want to assume a standard deviation of 0.02. I would want to change this to 95% so that you get a better idea on how to compute the critical value. So let's change that to 95%. So first step, we would want to find the critical value. Mind you, the critical value does not come from a normal distribution. I meant to say t-distribution, I'm sorry. Critical value does not come from a t-distribution. The reason being, the t-distribution depends on the degrees of freedom, which in turn depends on the sample size. But our objective here is to determine the sample size. So we don't use a t-distribution, rather we use a standard normal distribution. That is, it has a mean of 0 and a standard deviation of 1, and in the formula z sub alpha over 2 would be that critical value that comes from a normal distribution, standard normal to be precise. So here I have a bell curve, which is a normal distribution. Since the confidence level is 95%, this would mean the value of alpha would simply be 0.05. We have to take that alpha, divide by 2, and the area on the right tail would be 0.05 over 2, and the area on the left tail would also be 0.05 over 2. So we have negative z sub 0.025 and positive z sub 0.025. So how do we find that critical value? Since this is a bell curve, we are going to use inverse norm. Put the area below, which is 0.025. That gives us negative 1.96 on the left-hand side, which would mean on the right-hand side it is positive 1.96. Excuse me. So we have found the value of z sub alpha over 2, which is 1.96. The assumed standard deviation is 0.02, and we want the new study to have the weight of the penny within 0.005 grams, so the margin of error is 0.005. So what is the sample size? The sample size is z sub alpha over 2 multiplied by s divided by 0.005, excuse me, squared. So we have 1.96 times 0.02 divided by 0.005 and squared. And we get a sample size of 61.465, and we round up to have 62 pennies. So the new study would require 62 pennies so that we have a margin of error of 0.005 in finding the confidence interval for the average weight of a penny with 95% confidence. So before we end, just going to mention how we can find the confidence interval using the calculator. So the answer to that is simply t interval. So what we did here is we found the mean, the standard deviation, and we went through this 5-step process to find the interval right there, which is that. So now I already have the data in the calculator. So I have the data in list 1. So what I'm going to do is I'm going to press start, over to calc, and I'm going to, over to tests. I'm going to scroll down to number 8, and I have data and I have stats. So I'm going to select data because I have the data in list 1. So it's in list 1. So down. We pick a confidence level of 0.99 and enter. We get the exact same answer, which is 2.4516 all the way up to 2.4767. Now, instead of simply using the data directly, we can use the statistics that we found. So in this problem, it is not necessary because we have that information, we have the sample, but if you want to, we can use the statistics. So the mean that we rounded is 2.464, which is right here. And the standard deviation that we rounded, and we found that value as 0.0177. The confidence level is 99, so we leave it as 0.99. Hit calculate. We end up getting the exact same answer. Could be slightly off by a tiny bit, and it typically happens due to the sample size. So that entire process can be accomplished using the t interval. And keep in mind that if you have the data in hand, you can simply use the data option in t interval. But if you don't have the data, but you simply have the statistics, which is the mean and the standard deviation, then you could use the stats option to find the interval.